just wanted to do a couple more examples of these complex fractions from class. So here's one more example, just so that we really get comfortable with this idea of clearing these fractions. So again, I want to think about what the least common denominator is going to be. So if I listed out what my denominators are, I've got u squared twice, and then I've got u twice. And so if I consider what's the smallest number that u squared and u go into, clearly it's going to be u squared. So my least common denominator here is u squared. So I'm going to go ahead and multiply this fraction by u squared over u squared. And so when I do that, it can help me to write this u squared as u squared over 1, just so I realize that I'm multiplying it a fraction by a fraction. And so the same thing here. Okay, so here I've got a u squared, and because this is an addition problem, I'm going to distribute this u squared over these two terms. And same thing in this bottom, this u squared is going to get distributed. So taking a look at the numerator now, I've got u squared times 2 over u squared. I'm going to rewrite that here. So I've got 2 over u squared times u squared over 1. That's my first term. And then I'm going to distribute this to the second one, which is plus 4 over u squared times u squared over 1. I haven't canceled anything yet. I'm just showing you what the steps are. And then in the denominator, I'm going to distribute this across here. So I've got u squared over 1 times 8 over u. So that's 8 over u times u squared over 1. And then I'm going to subtract from that 2 over u times u squared over 1. And now I'm just going to go ahead and simplify any of those fractions that I can. So here I've got a u squared in the denominator and a u squared in the numerator. And so that will leave me with 2 over 1, or 2. Here I've got a u squared in the denominator and a u squared in the numerator, so that leaves me with 4 over 1, or 4. So 2 plus 4 in my numerator, divided by, here I've got a u squared over a u, so that cancels down to u. So that's 8u minus, this u cancels with the u squared to leave me a u in the numerator, so 2u. So notice all of those fractions canceled out, and I'm just left here with a nice typical fraction. 2 plus 4 being 6, and my denominator is 8u minus 2u, or 6u. And here I can simplify this a little bit more because I've got those 6's in the numerator and denominator, so it's just 1 over u. Okay. One more example. Oops, what happened here? One more example just to make sure that that's clear. So here, again, I'm going to find my least common denominator. And so I need a 4 and an x. So 4x will be my least common denominator. I'm going to multiply that numerator and denominator, which is just a version of 1. So I distribute it across. Here the 4's cancel. Sorry, I'll start at the top. So I'm going to distribute that across. So the x's cancel, so I've got 16 plus, here the 4's will cancel, so I've got x to the third. Here the 4's will cancel, so I've just got 9x. And here the x's will cancel, so I've got plus 12. Okay. And I can't simplify or factor anything in the numerator, so it's just x third plus 16 over, I could technically factor out a 3 here and be left with 3x plus 4. But nothing there is simplifiable, so that's my solution. Okay, so I hope those two examples help a little bit more. Thanks.